All right, so let's look at our next two examples. This is example 5 and 6 in your 7.6 notes. And again, the first thing I'm going to do is read through the problem, right? Look at the information that I'm given and look specifically at what I'm being asked to find. All right, so I'm told 1/10 of the total parts tooled by a machine are rejects. The question here says how many parts must be tooled if I need 4,500 acceptable ones. So again, I'm going to start and define my variable as the number of parts that would need to be tooled. Right? Basically my total. And then I'm going to use the information that I'm given to write an equation. All right, so we're talking about coming up with 4,500 acceptable parts. All right, so let's talk about just that for a minute and what that means. All right, remember I told you this in class too. Sometimes it helps me to write it out in words first. So the number of acceptable parts, right, that's going to be equal to the total number of parts that are tooled minus the parts that are rejects, right? So now if I plug in the values that I'm given, right, I need 4,500 acceptable parts. The total number of parts tooled, that's what I'm looking for. That is X. And then I'm going to go back and look at the fact that 1/10 of the parts tooled are rejects. And so I'm going to write the number of rejects as 1/10 of X, because remember, X is the total number of parts tooled. Now again, once I have my equation, then I just need to simplify and solve. So I'm going to combine like terms, right? 1x, this is the same thing as 10 tenths, right? So 10 tenths minus 1/10, I'm looking at 9 tenths x. And you may have written this as your first equation. If you just looked at this and said, okay, if 1/10 of the parts tooled are rejects, then 9 tenths are acceptable, you may have gone straight to this equation that I just wrote down, and that's fine too. It's also important to know that with a lot of these, there's not just one right way to reach the correct answer. All right, but at this time, I'm ready to solve. So the first thing I'm going to do is multiply both sides by 10. That's going to tell me that 45,000 is equal to 9x. Then to solve for x, I'm going to divide both sides by 9. And that's going to tell me the total number of parts that would need to be tooled to get 4,500 acceptable parts would be 5,000. All right, so moving into example 6, right, approaching it the same way. The information I'm given, an appliance repair shop charges $95 for the first hour of labor. They charge $80 for each additional hour past that first one. The total labor charge for an air conditioning system installation was $655, so putting those two together. And then what we're looking for is the total repair time. So again, I'm going to let that be my variable. All right, when I'm looking for one thing, I'm going to let that one thing be my variable. Right, X is the total repair time. And then again, I'm going to take the information that I'm given and I'm going to write an equation. All right, now like I said, if it helps you, write it out in words first. The total cost is going to be equal to the cost for the first hour plus the cost for each additional hour. All right, now I'm told that the total cost is $655. Now, if I look at the cost for the first hour, right, that's just $95. All right, that's a flat rate. And then I need to add to this the cost for each additional hour. Now, we know the cost for each additional hour is $80. But to make sure that I write my equation correctly, I want to note that this is only going to be the charge for those hours after the first one. So basically what I'm doing here is I'm taking the total repair time X and I'm subtracting 1 hour because only the ones past the first hour are going to have a charge of $80. All right, so here's my equation. Now I'm going to simplify and solve. So I'm looking at 655, if I get rid of the parentheses first, 95 plus 80x minus 80. Combine like terms. 95 minus 80 is 15 plus 80x. Subtract 15 from both sides. 640 is equal to 80x. And then divide both sides by 80. And I get a value of x at 8. Now again, we're looking for the total repair time, which is the value of x. So the total repair time here would be a value of 8 hours.